My name is Liang. I'm originally from Beijing, China, and now I'm working in UK. I'm a developer in European Bioinformatics Institute based on Cambridge in UK. I have been working on Drupal and Solr for many years. Do you guys know what is Drupal? Drupal is an open source content management system. You know, the website of the White House is based on Drupal. And I have written module for Drupal to use Solr to index documents in Drupal. Today, I'm going to talk about Edanz journal selector. That's a project I worked on before I joined the EBI. At that time, I worked for a company called the Edanz Group. They provide English editing service to scientists. We have two branches, one in Beijing, China, another one in Fukuoka in Japan. You know, Chinese people, Japanese, they don't speak English, but English is an official language in academic area. Almost all the publications must be English in the scientific world. And we provide this service for many years, and gradually we found the language is not the only problem for scientists. Another problem is journals. There are so many journals. It's impossible for scientists to know all the journals, even only for his own field. For example, PhD students is a typical group of our customers. They need to publish papers to graduate, but they are new in this field. It's impossible for them to read all the journals about their studies. Then we start to build a tool for them. It's called a journal selector. I will show how it works. Okay, this is the website of Edanz Group. This is journal selector. I will find the article. This is a journal called BMC Bioinformatics. Let's find the new articles. Oh, maybe this one. Just assume I'm the author. I wrote this paper. I want to publish it, but I'm not sure about the journals. So I can take the abstract of my paper and put in the journal selector. Find the target journal. BMC Bioinformatics ranks first for this paper. And also other journals. Algorithm for Molecular Biology is a multidisciplinary journal. It's also fit for my paper. Machine learning is about computer, but let's see the content about use MapReduce, very cutting-edge technology. Is also suitable to publish on a computer magazine. And if I click the journal, it shows why this one was recommended. Here is the topics. The topics in my abstract, and they was published in this journal before. And also in here, we can find similar journals published by, similar articles published by this journal. Are you familiar with the ranking system in Lucid Solr? Probably you may know there is an important concept, TF, IDF model. It's a term frequency and inverse term frequency, two important variables in the ranking system of Lucid. These terms, they are really specific about this study. They are displayed here because we analyze the IDF. These terms, they have high IDF value and show the uniqueness of this study. So by analyzing these terms, we can compare to the history data from this journal. The more match we found, the high is the rank of the rank is the journals. So you can see the good, excellent, how we rank the journals by these topics. And also, in here, we use the same way to recommend the articles to explain why we recommend this journal for you. Okay, to achieve this function, we need a lot of data from the history to know what these journals published before. The biggest data source for us is open access data. We have to thank to PubMed. It's one of the biggest open access data sets about the articles from more than 20,000 journals. They are all open, well-formatted XML. So we can know what these journals have published before. This data set is mainly focused on biology, medicine, also chemical, some part of physical. And after that, we built a tool. We found in these fields, the recommendation quality is the best because they open the data. We can get the best data. Another data source is fees. We found a project hosted by a UK university. It's called the Journal Talks. They collect fees from the journal's websites. And do you remember this logo? It's a logo of Google Reader. It has been closed, but at that time it's still open, and they have an unofficial API. They have crawl all the feeds and collect the data. We use the unofficial API, collect the articles, the data for these journals. And Springer is one of the biggest academic publisher. And Springer is our partner. So we can access their API without any limits and collect all the historical data from them and to know what they have published before. With all the data, we can start to build the journal selector. It's based mainly on open source stack. We host the web service on Amazon, AWS, and we use Hadoop and Hive to process the data and generated the index with Solr. The web service was provided by Drupal, and also we use the open source project called pweek to track user behaviors. So here are three main data sources. We connect the API to our partners, and we collect all the feeds. For the journals which were not covered in this data source, we have to write our own spider, mainly based on Hadoop, based on Nutch. We crawl their websites, and if they publish their articles or have the abstracts of their articles, we can harvest them and put them together and store in Hadoop in the HDFS. It's like a big table. We unify the format to have the journal titles, the abstract, or their full text, and the year from which journals. With Hadoop, and we also try to use Hive to do a like SQL group by operation to generate the index for the journals. And there is another index as well. It's not the journal index is not the only one. I will talk about that, the second index later. So the widget you see is hosted by Drupal. If you check the source of the website, it's only okay. Here is a one-line JavaScript. You can put this JavaScript in your blog to have the same widget. We use Drupal because it's an easy way to provide a web interface. We can let the no technology people in Edanz group to control the widget and display in different ways. This is a Springer journal selector. We can limit the results into our partner journals and provide different interface. It's blue, now the communism red theme. Also, we can provide different language, Chinese, Japanese, focus on different markets. Okay, here is the technology challenge for us. One of the biggest challenges is scalability. I have mentioned we have two indexes. One is the journal index, another probably you found is the index for the articles. Because the total number of the academic journals is still quite small in the search area. We don't need to worry about the performance. After we do all the data processing, the index is not very big. We can always run it in almost real time. But for the articles, each journal have published so many articles, and the total number of the articles of all the journal we covered is really huge. Fortunately, we only need to display the articles inside one journal. So we can take advantage of the distributed query of Solr. At that time, there is no Solr cloud, but the distributed query was already there. So we created index charts. All we need to pay attention is to put all the articles in one journal, in one index. Don't put the articles in one journal into multi-index. So the ranking system will always work because we only get the result from one index. I think you may know that the scoring system of Solr is based on the TF-IDF. It can be only calculated inside one index. If you have two indexes, the scores are separated. So we avoid this problem because we don't need to do the cross-index query for that. And another challenge is the internet ecosystem. You know, in China, we have internet censorship, and we build a system called Great Firewall. It's extremely slow to visit foreign websites from inside China. And we can't access Twitter, we can't access YouTube, we can't access Facebook. Thanks to Amazon, they have a different location for the data center. We built a Nutch spider and deploy on Tokyo data center. At that time, we got the overall performance is the best in Tokyo. We can access websites all around the world with almost the same performance. And we gather the data in the Tokyo server and build the index outside of China. After we build the index and we copy that back to China. And also, we have different target market. We have the journal selector deployed in Japan, in China, and also in Europe. You know, Springer is based in Germany. So we provide the Springer journal selector for them, and we host that in Europe. And all the infrastructure are based on AWS. I think I need to mention that we launched this application in around a little bit more than 3 months. And I'm the team leader for the developers, and we recruit one Java developer. a sister admin and a junior PHP developer. I need to manage the team and also do some developer work. You see, the team is very small, and the total time we spend on this project is not very long. We have to thank to all the open source projects and also AWS. Probably they need to pay me for the advertisement each time I make this talk. I recommend them. It's very flexible and make it possible to deploy the service around the world and don't need to worry about the different internet ecosystem. Okay, I was supposed to deliver this talk last year, and today is 3 years after we launched the journal Selector. There have been many things changed. One thing is the hardware is very cheap today. I just got this shopping list on Amazon like 1 week ago. You can buy a SSD with around $100 and a huge hard disk, less than $100, and the memory is also cheap now. So today, if we think about the data size, I think probably for less than 5 TB, we don't really need Hadoop. And it's much easier for one machine and the program to process all the data. But for 3 years ago, we need to use multi-machine to handle the whole journal, whole article data set. And I think it's still a right technology decision. I have left this company, and today they're still running that tool, and the data set must be increased. So with the Hadoop system, have all the Apache stack, no matter, well, not unlimited, but for general speaking, you have like 10 TB data and even more. You just need to add more machine. And this stack, Hadoop, enable you to increase the machine to solve the big data problem. Okay, questions?
How do you generate a query when somebody pastes the abstract?
How to generate query?
Yes.
Oh, that's a secret source. We use the open source projects, but we also developed a specific component to handle the technology text. And we, as I mentioned, we reuse the ranking system from Solr Lucene. And we can, as a demonstration, we can get the most important topics from the user's articles. From the text input, we found what is the feature keywords. I use that to compare with the historical data.
So I understand that it's secret sauce. So can you tell us a little bit about what the query expands to? Is it a complex Boolean query?
It's complicated Boolean query. Each query takes definitely more than 1 second. And it's even slower 3 years before, but it's not Google. We provide recommendation, and scientists, they're patient about that. It takes around like 2 or 3 seconds to get the results, and it's much complicated than the daily search.
How often do you re-index those journals?
We have a database, what we have crawled, or which is the data source for each journal, feeds or API, and put in a universal format, and we track which one we have got and which time we update it. Generally speaking, we relaunch the widget for each month and update the index at that time. Do I answer your question? sorry, I can't.
Like the Nutch analysis, you put this text and you came up with the match analysis, you put this test and you came up with this list of what? Map reduce to algorithm, right? It's these words into one base somewhere, you have a list of wording that you look for into a text, or how do you come up with this list?
You can think like this. We analyze the text input.
Yeah, but why you did not come up with molecular, like, into this test? You came up
These
with molecular.
keywords have higher inverse, higher IDF value, inverse documents frequency. This value shows the unique of these keywords. How unique is this keywords among all the docs? In here, the docs means is a term of the Solr index. I think you know the Solr index format. Each record called a doc. Mm-hmm. In this case, is a journal. So in this journal, BMC Bioinformatics, these keywords have higher IDF, so that's unique scientific topic. Do I answer the question?
Did you have to put them into the Solr index to get that IDF, or did you calculate it yourself?
After user input the text, we do the real-time analyzing to get that.
So you do it yourself, you don't put it into the main Solr index to get the IDF, you calculate it?
When we index the articles for all the journals, at that time, all the articles need to be calculated. We got the TF and IDF of all the historical data in the index.
Okay. I had another question. The index for the journals themselves, is that a very large document that contains all of the articles for that journal, or is it just a summary of the articles for that journal? Like you said, it was a very small index, but is it a small index with some very large amounts of text in it?
Yes, it's depending on the data sources. As I mentioned, some open access journals, they have full text. And for some journals, they have summaries available for public.
So would you put it all, whatever you could get into the...
First, we get all the data we can, and then we normalize a little bit. And also, we need to consider the frequency of the publication. Some only publish like half a year, so we have a normalization for all the journals. But still, if the journal have open access data, publish the full text, they have better quality in the recommendation. More questions?
How huge your index is? What's the index size?
What's the size?
What's the size of the index?
I think it's difficult to say today because it's a project for 3 years and they have changed something. At that time, the index is not bigger than 1 terabyte. It's very small. And for the index of a journal is much bigger. And at the beginning, we use 1 index, and later we split into shards. And also, for some cases, we talk with journals. Some they want to have testing, or we generate specific index for them, and we add index like this way, add new journals in a new index, and put the index together to use a distributed query. Okay.
What do you do with Drupal into this your stack? Is it just the front end to send a query to this your index? What is Drupal doing into this your stack?
Drupal provides the one-line JavaScript, and it renders the interface. And after user input the text it will be sent to Drupal first, and Drupal will use that input to query Solr, and Solr give back the results, and Drupal will render the results into HTML, and also provide the interface for managers, and also connect with the user tracking system pweek. Because Drupal is very flexible, you can add your own custom module and with other library, so it can shorten our development, make it possible in 3 months. More questions? No. Okay. We still have a little bit time if you have any question. Okay. Oh.
What's the impact score?
Sorry.
The impact score, that was one of the scores when you would do the search. Give an impact score next to the relevancy.
Here?
The impact factor, yeah.
Here? Impact factor is a value created by Thomson Reuters. It's a ranking for the journal, how important is the journal. For example, natural science, they have higher impact factor. And in here, you can filter the journals by the impact factor. For example, in China, if you publish a paper, if it's on a high impact factor journal, probably you will get promotion or get better salary, something like that. So it's a useful function for them.
It serves mainly as a filter. Does it affect relevancy?
It's just a filter. The relevancy is all about the text, the topic. No more question? Okay.